All right, welcome back, everyone. It was so good to talk about our unsung hero, Nitro system, and the benefits of security that it brings to all of our customers. We're going to switch gears a little bit, though, and talk about one of our newer heroes, Nitro SSDs. With us, we have Amit. Amit, do you want to introduce yourself and tell us a little bit about what you do at AWS?
Sure. Amit Shah. I'm the product manager for EC2 and predominantly look at all the storage optimized instances that you guys are using for your storage workloads.
Yeah, I think maybe we can talk right off the bat about what are SSDs and maybe offer a definition first. What are SSDs, right?
I think that's a great way to start the conversation. What in the world is SSD? So SSD really stands for solid state drive, and what it really is that it's a storage device that can map the data persistently into flash memory. Now, if you compare that to hard disk, which has been there for many years, hard disk really maps the data into a spinning platter magnetically, versus in SSDs, all of that data is in silicon chips. That's why SSDs are significantly faster in terms of latency, and deliver significantly higher amount of throughput compared to hard disk. Like one good example of SSDs is going to be like laptops, like all the new generation laptops, or I should say the high-end laptops. You will see that they are very responsive in terms of the boot up time and responsiveness to your controls and commands. That is predominantly because it has SSDs. And AWS was one of the first pioneers in bringing SSD at scale into cloud. So we introduced SSDs 10 years back, and since then SSD has been one of the top storage media for storage workloads.
That's pretty significant. So 10 years ago, we started this journey using SSDs in the cloud, a space that I don't think that people had thought about placing an SSD beforehand. So it's taking it from a product that many of us have on here, in this case, on the table here, but into the cloud, providing those additional, if I will keep my term, efficiencies here as well over and over again. So, excuse me, maybe one of the things that when we've talked about the SSDs, we talk about latency as well, and customers talk about latency. So maybe you can talk about what latency is and how it is measured and how SSDs can help improve that.
Sure. So I think let's talk about the latency is really about the fact how much time does it take for you to access the data, and then meaning you initiating the access, the SSDs collecting the right amount of information or the data from the flash devices, and then returning it back to the application. That is how it would we would characterize it. So when you think about low latency workloads, I think there are a couple of things which are really important, which utilize SSDs. One is that these workloads require a high amount of capacity that can be accessed at low latency. So imagine workloads like EBS, block storage, elastic block storage, or EFS, elastic file system. They have got huge amount of data that cannot be simply mapped into DRAM, which means that they need a storage media like an SSD, where all of this capacity can be mapped and can be accessed at a significantly shorter amount of time. On the other aspect that you want to think about is latency in terms of transactional databases. Here, what you want to do is you want to read, update, and then rewrite that data. So read, modify, write, transaction, and you want to complete all of that before accessing that data again to ensure that the data is consistent. Again, in this particular case, it is really important that the SSD characteristics are taken into consideration, because how fast a database is depends on this SSD characteristics. Let me give you like good examples of how you use low latency workloads in your real world application. Right. For example, think about file sharing apps, or trying to book a Uber or a Lyft service, or trying to buy a concert ticket, and suddenly things are getting done in split of a second. Think about shopping at Amazon.com, and here you can go there, few clicks, and voila, you are able to place your order. And something as different as ad tech. And now what ad tech really does is think about all the magic that happens behind the scene, where suddenly on your browser screen an ad pops up, or on a social media screen your ad pops up. All of these workloads are taking advantage of low latency storage.
Yeah, and this, I think, gives us, sometimes I think we forget about where we have been with storage and where we are now, right? I mean, you talked about the file upload. I think all of us are from, a time and generation where, you're waiting for whether it's Napster or something to upload content. And you're like, am I going to be listening to that song today or what have you? But we're now all accustomed to, it's so good that I can place an order for an Uber at the corner here, where we are in Seattle, and have it, come over immediately. And that's an algorithm that's running behind figuring out where the vehicles are and placing there. And that all relies on access of storage and content, right? Data that has to be delivered.
So then do customers run these low latency storage workloads in the cloud already, or is this something new?
That's a great question, Martin. So I think cloud has led the way in terms of low latency databases and file systems. So we have been running this for quite some time. And one of the flagship products that we have is i3, which is a leader in terms of storage performance. So we see tremendous amount of workloads running on these instances today. Now, if you think about our own internal services at AWS, DynamoDB, EBS, Redshift, all of these take advantage of the low latency infrastructure that AWS already provides. Now here again, I want to clarify that when we talk about low latency, I'm not simply talking about the fact that, hey, latency on an average. We're really talking about latency when the server is doing something meaningful, which means that it's literally running your workload and trying to deliver throughput to meet your business requirements. And optimizing that particular part of the latency is what we would care about.
Yeah, and I think the other thing as we look at this latency, maybe could we talk about how this latency briefly can help with managing someone's carbon footprint, just to kind of finish that out, right?
Yes.
Because this is key.
Yeah. So carbon footprint has been very important and has been gaining a lot of momentum, I would say, within our customers. And one way latency can really help is with reduced latency, you are able to drive higher amount of throughput for a given latency and still meet your SLA. And what it really does is pushing the server to deliver more throughput reduces your carbon footprint per transaction. And that is how we have seen latency translate into real change or real difference in the carbon footprint.
So that's really cool to me, at least as well. Both it kind of, I don't think we always think about, all of the different aspects that this latency and storage has. I think a lot of times people think of storage as just like a block of stuff that's placed there, right?
It's fantastic. Get better performance and help the environment at the same time.
Right. I mean, this is kind of like, and also, I think we'll hear from customers and we'll talk about some customer examples where this low latency is key to the operation. And we'll talk a little bit through some of those examples as well. But, maybe we should talk about what are kind of unique low latency workloads that are out there that are particularly important here for the SSDs.
Sure. So I think before I jump into the specific workloads, let me clarify what are the unique requirements that these have, and then I'll dive deeper into the workload. So the number one thing that these workloads require is high degree of latency predictability. So this is by far the number one requirement. And what I mean by this is that when the workload is accessing the data, which happens to be in the SSD, they want to access the data, analyze it, and the amount of time they spend there is very, very important, and hence the SSD characteristics are very important for them. So now if I have to give you an example of some workloads, then I would say think about workloads like MySQL, Oracle database, Microsoft SQL Server, or NoSQL databases like Aerospike, Couchbase, Cassandra. All of these desire low latency and significantly lower latency variability to meet their SLAs. I think one of the key products in real-time database is Aerospike, and they are extremely sensitive to latency variability to meet SLAs of less than 200 millisecond, and us optimizing latency for them is hugely important to them. And not only that, not only these workloads, think about the workloads that we at AWS enable. Think about DynamoDB, Aurora, EBS, Redshift. All of these, again, feed us all the requirements that we have. Now, one other area that is really interesting is that before Nitro SSD, I would say before Nitro SSD or even today on on-prem, what you see is that the low latency workloads, sometimes customers run them at a lower server load. And the sole reason that they do that is they want to make sure that they don't stress out the server, which in turn stresses out the storage and create latency spikes. They want to avoid those latency spikes, so they're so sensitive to that. Yeah. So if we talk to them, what they really desire is an ability for them to continue to reduce their cost, which means that they want to drive more throughput through their server, and hence they want a more reliable storage solution which can deliver a consistent performance at higher throughput to meet their overall TCO objectives.
Yeah, this is huge. We should probably say what TCO is now that define that out,
yes,
right?
Yes.
So for those who don't know, right, it's total cost of ownership.
Total cost
right?
of ownership. So, like being a product manager for a long time, so stuff happens.
I know we use a lot of three-letter acronyms
exactly,
at AWS,
exactly.
but I think it's just in case anybody doesn't know.
So we talked a little bit this morning about the motivation behind developing Nitro system and Graviton, but we didn't touch too much on the motivation on Nitro SSDs. Can you talk a little bit about how AWS decided or why AWS decided to build our own Nitro SSDs?
That's a great question. We have been working with workloads in cloud for 15 years, and we have understood the pain point that our customers have in terms of latency, performance consistency, and reliability, and that was a big motivation for us to really develop and innovate on behalf of our customers. But before we even put the Nitro SSDs into our customer's hand, we dog-fed the solution to power up our IO2 block express EBS volumes. And this was really done to deliver significantly high number of IOPS, very high throughput, and deliver 64 terabytes of max EBS volumes.
So even though Nitro SD became available in EC2 instances this year, it's actually been in use for quite some time in EBS.
Quite some time, yes. And we use that opportunity to continue to improve on security, reliability, and throughput at cloud scale. Now that said, as you guys are aware, that we recently launched IM4GN, IS4GN. These are the Graviton-based instances with Nitro SSD at reInvent last year, and then I4I, which was announced in April of 2022. Again with Nitro SSD, but guess what? That is the second generation Nitro SSD. So what we really did is we took all the learnings from the first generation Nitro SSD, and then on top of it, we further optimized the performance to reduce the latency spikes and deliver consistent performance for our customers. So that is how the whole Nitro SSD story came together. Generally, I think I would put it this way, which is what really the theme of this today's topic is, that we look at technologies and we really figure out, okay, how do we want to address customer issues by innovating with silicon? And Nitro SSD is just one of the examples. We have the Nitro system, we've got the Nitro security chip, high performance, low cost machine learning chips like Infertia and Trainium, and then the 3 generation of Graviton processors. Now we also have the 2 generations of Nitro SSD to join the bandwagon.
Yeah, and you also mentioned something, and I feel like we almost go too quick over this, but we have introduced 3 Nitro SSD products in the last 12 months, right? We most recently introduced i4i, which is the follow-up, as you mentioned, to i3, right? But we also introduced our 2 Graviton products last year. I mean, Martin, that's super cool, that the idea that not only have we introduced something, we've introduced several in 12 months, under 12 months.
Really quick innovation, and it's great. It's not just about having one silicon innovation working in silo. It's like you have Graviton, which is proven CPU. Now we have Nitro SSD and putting it together. So it's awesome.
We always believe in giving customer choices and giving them choices to continue to improve their price performance and reduce their total cost of ownership. And Graviton is a great vehicle for us to deliver the best compute performance clubbed together with the best storage experience that they can get.
Right, and we'll talk even more about the flexibility and the need for customers to be kind of willing to look at these multi-architecture approaches as well themselves when we talk about the cost later in the day as well. But it's key, that's why we have the offering in multiple spaces, right? Mm-hmm. We have the IM4GN and we have the i4i, and it's kind of like gives an offering to meet customers where they are, if you will, right, Martin? Yeah. I think that's one. We want to. I think as a general rule of thumb, we're trying to make it as easy to migrate to the cloud. And then once you're using the cloud, easy to utilize the systems that we have and access the benefits as fast as possible.
Yep, absolutely.
So,
oh no, go ahead.
No, I was just gonna ask about, how can these SSDs actually be used, and how can they improve the posture, or if you will, operational posture for someone using AWS?
Yeah, so I think the way Nitro SSDs improve our operational posture is that whenever there is a reliability or performance anomaly that is experienced, then majority of the time we have found that these anomalies are really rooted into the SSD firmware, and if we have to deal with vendor SSD solution, then it takes a long time to really address these kind of things, versus when we have our own Nitro SSD and the fact that we own our own firmware, we are able to address some of these anomalies at a very, very fast pace, and we can literally deploy the fixes at cloud speed. So that way it has been really a blessing, because any such concerns can be from our customers can be addressed significantly faster compared to the vendor SSDs that we use.
So exactly how fast are we talking about? Like what kind of performance?
So in terms of performance, Nitro SSDs would deliver up to 60% lower latency and up to 75% lower latency variability compared to our previous generation storage instances, which, by the way, were already flagship at that point in time. So compared to our previous generation flagship products, 60% lower latency, 75% lower latency variability. And what this results is the fact that now these Nitro SSDs can deliver up to 4x more throughput for a given load for a given amount of latency. So that's a significant improvement in the bare bones storage performance.
Yeah, I would say this is a gargantuan improvement. At 75%, I mean, if you got a 75% raise, you would consider it, right? Yeah, no, I know. Shout out. But I think one thing we maybe talk about that 75% reduction and what we're talking about and how that is manifested for customers. I think that we have this 60% and 75%. I maybe break this down a little bit further to get a little bit more detail on it.
Sure. So I think the latency improvements that we have driven and performance consistency improvements that we have driven in Nitro SSD, if you go back to how does it impact our customers, is that Redis and SkylarDB tested the i4i instances, and they are able to see up to 2.7x, 2.7x improvement in throughput compared to the previous generation i3 instances. Not only that, Aerospike, a real-time database, they were able to see 70% improvement in their read throughput with Nitro SSD-based system. So that's a significant improvement. Now, if I talk about the Graviton instances, both Splunk and Sprinkler, they saw 50% reduction in their search runtime for their indexer and search workloads. So all of this literally benefits into real-time workload performance that these customers desire.
This is really cool. And just as a note, I think Splunk, we heard from Splunk and Derek at Splunk just talking about the importance of low latency just before we started talking here. So we kind of like tying all this together here. So it's great to hear from customers about the excitement of using it, but it's also interesting on the real world impact, right?
It was really exciting journey for us to work with Splunk. They were one of the initial customers for IM4GN and IS4GN, and we had an amazing time trying to figure out, okay, how do we take advantage of Graviton and Nitro SSD to really boost performance and reduce the cost of ownership.
Incredible. Yeah, so all these amazing performance benefits are simply fantastic. But I want to get a little bit under the hood now. SSDs have been around for a while. What makes AWS Nitro SSDs unique? Like, what's the secret sauce or IP here?
That's a great question. What is the secret sauce of what we do? So I think let me tell you a little bit of background here. So what SSDs are? They are built on using very fast, dense flash devices. And one of the characteristics of flash devices is that you can write, erase, and rewrite only for a limited amount of time. So for you to make these devices live as long as you would desire, what you really want to do is there is SSD firmware that manages the flash and manages the write that goes into the flash, so that the writes are evened out across all the flash devices. Now, when you deal with OEM SSDs, what we have seen is that the response time has been very variable, or it creates, there's a lot of uncertainty in the response time, especially when there's a scenario where they're bombarded with a lot of writes. And that really causes the latency spikes that our customers really don't like. So what we have really done is we have taken control of the whole SSD firmware with our experience of working with cloud customers, with our expertise using databases. What we have really created is a sophisticated, power fail-safe journal database that can, which we really call it as the flash translation layer integrated into the SSD firmware, that can significantly reduce the SSD spikes. And we didn't even stop there. What we then did is we integrated the flash translation layer with the Nitro system so that we can deliver consistent performance for our customers' workload. So again, it's a combination of the fact that we have our own flash translation layer and we integrate everything with the Nitro system to deliver this unique capability.
Yeah, I love how we spent a lot of time talking as well about integrating both the hardware and the software together, because that's about making the system, creating system improvements or efficiencies as well, like throughout this entire way. If you aren't kind of spending time thinking about both that hardware and software connection, that's where you can lose performance and customers can see impact as well. So this is a kind of a really great story on the IP side that we have worked on here.
Yep.
Oh, maybe we should talk a little bit about the specific instances here. We spent quite a bit of time telling the story about the IP behind it. So maybe we could talk a little bit about the performance of the IM4GN and instances here.
Yeah, so we launched IM4GN and IS4GEN at reInvent of last year. These instances are powered by Nitro SSD. They have up to 30 terabytes of Nitro SSD, delivering 60% lower latency and 75% lower latency variability compared to the previous generation instances. And they use the Graviton 2 processors, which gives them the best possible compute performance that we have on the storage instance family. If you think about IM4GN, it is comparable to i3 instance, and it offers up to 44% lower dollar per terabyte and 40% higher price performance compared to i3. And then IS4GEN is comparable to i3EN instances. It's more denser in nature on a per vCPU basis, and it delivers up to 15% lower dollar per terabyte and up to 48% higher compute performance compared to i3EN. So again, significant improvements and more choices to our customers.
Absolutely.
Yeah.
I mean, whoever thought we would be talking about 30 terabytes as if it's like 64K.
I know.
But it just is a representation of how much data customers are working with and needing to process very quick to make a decision or to make an accurate recommendation. To someone.
Yeah, that's just incredible. Improvements on the storage side and improvements on the compute side as well. So not to forget, we also launched i4i this year as well. Can you talk a little bit about that as well?
Yeah, so i4i launched in April of 2022. And again, we have 30 terabytes of Nitro SSD delivering the same Nitro SSD performance benefits, but it's also launched with the latest generation Intel-based Ice Lake processor. And what we really deliver is 30% price performance benefits compared to i3, significantly better storage performance, and more network, more EBS bandwidth. So it's a drop-in replacement for i3 instance, but with a lot of goodies packed in.
That's amazing.
Yeah, I mean, I think a lot of times, you think about memory and, it doesn't seem always as exciting, but I think that once we start to talk about the impacts to customers about how these benefits can translate into customers, I think it's really, really key in being able to talk to customers about and define what we're able to do for them.
Yep.
So maybe we kind of wrap up here with like what's next. After all this, what's happening as well.
Yeah. So I think that is exactly what my team works on. By the way. So yeah, we have just begun the journey of Nitro SSD, and there are many more things that we are working on. So I think what I would tell the customers is that what you should really expect is in the future, we are going to be bringing in more enterprise class storage features or features which are going to benefit storage workloads into Nitro SSD. So think about features which are either not available on-prem today or are available in very expensive, ridiculous cost on-prem. So we are going to bring those features to cloud with the Nitro SSD. So that is one. We're going to continue to reduce cost. So that is something that will always help our customers, and then we'll continue a journey on optimizing for latency and driving more consistent performance.
Well, that's pretty impressive here. So I want to thank you for joining us today. And I think one of the important things is we talked a little bit about some customers here. We talked about, the lead-in here to our segment was on Splunk, but I think an equally important customer and partner that we talked quite a bit about as well is Aerospike. And I think coming up next is we're going to hear a little bit directly from Aerospike and from one of the founders of Aerospike about their usage of the Nitro SSDs. And so I think that it's kind of cool to be able to hear directly from a customer and get that going.